Hey, welcome. This video is on graphing polynomial functions. Let's go ahead and start off with an example. We're going to graph f of x equals x to the fourth. Okay, so notice that there's no parentheses. So that's what I want you to think about first. Are there any parentheses? And if there's not, then we're going to just start with 0. Okay, so we're going to start with 0, and then we're going to pick two numbers to the left and two numbers to the right. Similar to graphing a parabola. Same thing with a parabola. We start with 0 and then two numbers to the left and two numbers to the right, unless there are parentheses. So underneath the x, we'll put 0 in the middle, and then to the left of 0 would be -1 and -2. And to the right of 0, right, 1 and 2. Okay, then plug those into the function to work out the y values. You could pause the video always and work it out. All right, so like when you plug in -2, -2 to the fourth power would be +16 because there's 4 negatives. Also, you should know how to use your calculator. Your calculator will make a table for you. Most calculators, I should say. All right, let's plot those points. And it's going to look kind of like a parabola, but it's not a parabola. It just looks like a parabola. All right, so plot those points. Okay, there we go. And now we'll draw in the sketch. Right, looks like a parabola, right? Okay, here's our next problem. This one does have parentheses. So what you want to do is when you make a table, you're going to pick the numbers. Well, you're going to pick the number that makes inside the parentheses a 0. So what number plus 1 would equal 0? Right, -1. Or you could think of the opposite of the number after the x. So it's a +1 after the x. So pick the opposite of that number, -1. Then we're going to pick two numbers to the left of -1 and two numbers to the right of -1. All right, so here are those numbers. So again, we said we were going to pick -1. That's our value right in the middle, -1. And then the numbers to the left would be -2 and -3. And the numbers to the right would be 0 and 1. And then plug those into the function, work it out, and there you see the y values already listed. All right, let's plot those points. This is a cubic function. So kind of note that the last function was to the fourth degree, had like kind of a U shape. This has this kind of curve. On the right of the middle of it, it's like the top half of a parabola going up. Or I should say it's one side of a parabola going up. And on the other side, it's like half of a parabola going down. Okay, so those were just monomials, one term. Now we want to graph polynomial functions in factored form. So what I wrote here is it is difficult to accurately graph most polynomial functions without using a calculator or some kind of graphing tool. But we're just going to try to do the best we can. This video is created for an algebra course, not a calculus course. So there's lots of tools that we don't know at this point. So we're just going to do the best we can with the tools we do have. Okay, it's always good to have a large number of points to get accurate graph. But if it's not so accurate, it's not perfect, it's going to be okay here. If a polynomial function p of x can be factored into linear factors, its graph can be approximated by plotting only a few points. Okay, using the factoring and graphing techniques available, a somewhat accurate graph can be achieved. For a complete discussion of graphing polynomial functions, tools of calculus will be needed, which is beyond the scope of this course. So, like I said, not to worry, we're just going to do a few things here to give us a pretty decent graph. Not perfect, but decent. These are our steps, and I try to keep it simple. Some instructors may have a few more steps. I try to simplify things a little bit. Right, here's our steps for graphing polynomial functions in factored form. Number 1, find all x-intercepts. And how we do that is we set all linear factors equal to 0. Then we're going to plot those intercepts on the x-axis. Okay, number 2, we're going to find at least one point between the x-intercepts and one point on the left and right of the outer intercepts. And then after that, that's good enough. Then we're going to draw in our graph. All right, let's do it. Okay, here's our function to graph. Notice that it's in factored form, so it's parentheses x plus 1, parentheses x minus 1, parentheses x minus 3. So step 1 was to set each factor equal to 0. So you're going to set each equal to 0, so x plus 1 equals 0, and then solve. X minus 1 equal to 0, and then solve. And then x minus 3 equal to 0, and then solve. So for the first one, subtract 1 on both sides, so you'll get x equals negative 1. The second one is x equals 1, and the last one is x equals 3. You could probably get those numbers by just looking at it. It's always the opposite of the number inside the parentheses. All right, so let's plot those on our graph. So put a dot on the x-axis at those three numbers. One was at negative 1, one at positive 1, and the other one's at positive 3. Okay, now we're going to make a table. And we're going to pick numbers to the left of negative 2, to the left of negative 1, in between negative 1 and 1, in between 1 and 3, and outside of 3. So like to the left of negative 2, what number is, sorry, I keep saying the wrong number. What's to the left of negative 1? Negative 2. And then what's between negative 1 and 1? 0. And what's between 1 and 3? So we're looking at the red dots, and we're trying to see what number is in between those red dots and a number that's outside of the red dots. So let's see, the last dot on the right is at 3, so pick a number to the right of 3, that would be 4. You could pick 5 or 6. But try to pick something close, because these numbers get kind of large very quickly. All right, so plug in each of those numbers into our function, or you could get the y values by using your calculator and using the table feature. Okay, so there we have it. Negative 15, 3, negative 3, and 15. Remember, if you don't know how to use your calculator for the graphing feature, try to watch a video on that if you can. Okay, let's plot those points. There we go. And now pretty much it's just connecting the dots. Try to go from left to right. So that one at negative 15 is where you start. I'm going to put an arrow there, and then keep going to the right. And there's our graph. Now just a little note. The points 0, 3 and 2, -3, those are called turning points. Because at 0, 3, see, it's not going up any longer. It's got to start coming down because it's got to hit the next intercept, the one that's at 1, 0. So we call it a turning point. And then once you get down to the bottom at 2, 3, -3, it's got to start heading back up because there's points going up. It can't keep going down forever, right? It's got to go back up eventually. So this one has 2 turning points. This is a degree 3 polynomial. If you multiply it all out, there's 3 x's in the original polynomial, so that's x to the third. So this degree 3 polynomial has 2 turning points. It's always n-1. Or it's at most n-1. So you could have only one. In this case, it has 2. So it has 1 less than the degree of the polynomial. All right, here's our next one. This was in factored form. We're going to set each factor equal to 0. I also want you to take note of the exponent on the x-1. It's a 2. That's going to tell us something about the graph. And we'll talk a little bit more after we're done. But let's take note of that. So let's set each of these equal to 0. And we get our intercepts. By the way, they're also called zeros. So if you see that terminology by your teacher or in another YouTube video or in a book, these intercepts are also called zeros. All right, so for the x that's in front, that would be 0, because if you set negative x equal to 0, divide by -1 on both sides, you'll just get 0. And for the x-1, that will be +1. And the x plus 2 will be -2. So let's put our 3 red circles, or red dots for our points, on our graph. One at 0, one at 1, and one at -2. There we go. Okay, let's make our table. Now we're going to pick a number to the left of -2. Maybe -3. We're going to pick something between -2 and 0. So how about -1? Now the 2 dots, or the 2 points on the right, 0, 0, and 1, 0, there's not a tick mark in between 0 and 1, so we have to pick a fraction. How about a half? Yeah, a half. Okay, so these are our numbers. Now, if you're using the calculator such as a Casio, to get the half, you probably want to change it to change your step option. So it's got a start and an end. It also has a step, so change your step to 0.5. And usually the calculators give it to you in decimals. You could change it to a decimal if you want to. So I wrote it to as a fraction, 5/16. Yeah, so on your calculator it'll be 0.3125 negative, but you can leave it as, I just wrote it as a fraction. All right, let's plot those points. Oh, -3, -48. Shoot. I could change the scale. Notice I didn't put any numbers here, so I'm just kind of going by ones. But if you want to, you could change your scale. You could go by -4 or by 4s or by 5s. You don't have to, and actually those two outer points, if you get ridiculous numbers like this, -48, you could just show that the graph is in that direction. You could change the scale, but then you kind of lose the accuracy. It doesn't really have the right shape. So here's the other points I plotted. I plotted the -1, 4, you can see that up there. The 1/2, -5/16, and the 2, -8. But I did not show the -3, -48. It's off my screen, right? So when you draw your graph, just kind of show that it's in that direction. There we go, something like that. So I just have an arrow showing that it's way down there somewhere. Okay, let's go back and look at the x equals 1. Remember we said there's an exponent, x minus 1 squared? Well, that intercept, what happens is, at that intercept, it bounces. It hits that point, the graph comes up, it hits that point, -1, 0, and then it goes back down. So it doesn't go through the intercept, it bounces at that point and goes back in the same direction. So anytime you have an even exponent, like a 2 or a 4, it's always going to bounce. If it has an odd exponent, it'll go through still, but an even exponent is where it bounces. All right, so yeah, just the last note there. I didn't label -3, -48. There should be a negative there, by the way. But I just show that it goes in that direction. And this is a degree 4 polynomial, right? There's 4 x's. The x minus 1 squared, since it's squared, that counts for 2 x's. The x plus 2, there's a third x. And then the x in the very front, that's the fourth x. So therefore, it could have at most 3 turning points. How many does it have? Let's see, so it goes from the bottom, goes up, it turns, it comes back down, and then it starts at 1/2, -5/60, it goes back up, so that's 2, and then at 1, 0, it goes back down, so that's 3. So it has 3 turning points. All right, here's our next one. Oh, again, there's that squared. That means that that intercept is going to bounce. It's going to go back in the same direction. All right, what are our intercepts? Right, -1 and -3. Let's plot those points. There we go. Now, what numbers are we going to choose for our table? Right, -4, -2, and 0. All right, good job. And plug those into your calculator. Verify that those are the same numbers that I got. All right, let's plot those points. And remember what we said about -1. What happens at -1? Right, it bounces. Yeah. All right, we're hanging in there, right? Let's do another one. So those previous examples, they were all in factored form. Well, what if it's not in factored form? Well, we need to factor it, right? So they need to be in factored form before we could follow those procedures. So we're going to use our basic methods of factoring, such as factoring out the GCF, factoring the binomial or trinomial, or maybe we do the rational root theorem like we did in the previous sections. If you have a decent calculator, you could also let your calculator help you to factor it. Remember it tells you the zeros. All right, here we go. X to the third minus 3x minus 2. That's x to the third. We can't factor it. It's a trinomial, but because it's x to the third, we can't do our factoring by grouping. So we're going to do our rational root theorem. Now, c over d is plus and minus 1 and plus and minus 2. Because our c is 2 and our d is 1. All right, so let's see. What you could do also is, use the solve feature on your calculator. So you don't have very much guessing. But if you want to not waste too much time, do that. Make sure you put a 0 in the x squared place. So it should go 1, 0, negative 3, negative 2. And then you might try 1, and then negative 1, and then 2, and then negative 2. All right, let's try negative 1. That's a good guess. So bring down the 1 below the line and work it out. I just went ahead and showed it all right there. Take your time and work through it though. But negative 1 works, right? So now we have 1, negative 2. Let's write that in variable form. And I believe that should factor also. That factors to x minus 2 times x plus 1. Now we also have the negative 1 in front that we started with. So that means x plus 1 is a factor for that negative 1. So we have x plus 1, x minus 2, and x plus 1. Or since there's two x plus 1s, we could write it as x plus 1 squared. So that's this polynomial in factored form. We have to have it factored so we could find the intercepts. So anytime we have a polynomial, if it's not factored, we have to factor it. All right, those are our intercepts, negative 1 and 2. Let's plot those on our graph. Now remember the x plus 1 squared, that means it's going to bounce, right? All right, let's pick points. To the left of negative 1, we should pick negative 2. In between the two intercepts, between negative 1 and 2, we could pick 0 or 1. Why not both, right? And after 2, to the right of 2, we'll pick 3. Plug those into your handy dandy calculator, work it out. Okay, plot those points. I did not put in 316, so just kind of note that it's like off the screen. So when we draw it in, we're just going to show that it's there. All right, let's sketch it. Remember at negative 1, 0, bounce. Yeah, there we go. All right, here's our next one. Again, it's not in factored form, so we got to factor it. Here's our c over d. We're going to do the synthetic division. Again, use your calculator. Like on the Casio, you might hit menu, and then the equation feature, and then hit the polynomial, degree 3, put in your numbers. And it'll give you the solutions. It'll give you 3, 1/2, and negative 1. So I already know what our intercepts are. Those are our intercepts. Let's start with negative 1. Do the work, and you'll get 0. All right, now write that in variable form, factor that. You could do the whole grouping thing if you want to, or if you could do it in your head, that's fine. That factors to 2x minus 1 times x minus 3. So now when we write it in factored form, don't forget we have the 2x minus 1, the x minus 3, and because negative 1 was one of our roots, or one of our zeros, then when you put it in factored form, it's got to be the opposite, x plus 1. All right, so now we have our three zeros, negative 1, 1/2, and 3. We plot them, make a table. So we're going to choose negative 2, and then the numbers in between negative 1 and 1/2, we could choose 0, and then between 1/2 and 3, let's choose 1 and 2. You could choose just one of them if you want. And then to the right of 3, we'll pick 4. Notice at a couple of those points, the negative 25 and 35, I'm not going to plot. I'm just going to show the graph in that direction. So negative 2, negative 25, that's way down below. So just make sure when you draw your graph, it's coming from the bottom. And there you go. Okay, here's our next one. The last two, we had to use synthetic division. I don't think we have to do that here. Let's look at our factoring. Is there a GCF? Yeah. The GCF is x, right? So let's factor out an x. X squared minus 4. Difference of two squares, right? What does that factor to? Right, x minus 2 times x plus 2. Okay, so let's find our three intercepts. We have one at 0, one at 2, and one at negative 2. Let's make our table. Let's pick a point to the left of negative 2, like negative 3. In between negative 2 and 0, negative 1. In between 0 and 2, 1. And to the right of 2, 3. Okay, I made my graph just big enough to get all these points in. Let's draw it in. Not bad. Right, it's getting kind of fun, don't you think so? Hopefully, really one of the keys is getting to know your calculator. Your calculator will give you the table, so we just have to plot the points. And we have to know which points to choose, though. That is also key. Let's do one more example. Okay, last example. All right, x to the fourth minus 4x cubed plus 4x squared. Can we do any factoring? Yes, GCF. What is our GCF? What do they all have in common? Right, an x squared. So the x squared goes in front, and then divide each term by x squared. So in the parentheses, we have x squared minus 4x plus 4. Now we need to factor that trinomial. So it's a 4, there's 1 and 1, 1 and 4, 2 and 2. So yeah, right, 2 and 2. Both negatives. So it's x minus 2 times another x minus 2, or you could write it as x minus 2 squared. So this one only has two intercepts, one at 0 and one at 2. And notice that the exponents are 2 for both of them. That means it's going to bounce twice. It's going to bounce once at 0 and once at 2. So let's plot those two intercepts at 0 and 2. Only two intercepts. Make our table. We'll pick negative 1, 1, and 3. All right, plot those points. There we go. Remember to bounce. So it comes from the top, goes down, bounces, comes back up, then goes down, bounces at 2, and then goes back up. Kind of looks like a W, right? All right, that's it for this lesson for polynomial functions. I'll see you here for the next video on graphing rational functions. Have a good day.